Alright, let's discuss right prisms. A right prism, well, I have three examples here of right prisms. And a right prism is simply this. You have a base polygon. For example, in this case, the base is a rectangle. And in this example, the base is a triangle. In this example, the base is a trapezoid. And the way to construct a prism is to make a copy of the base shape, a rectangle in this case, and duplicate it directly above the other base. So here are the two bases that are parallel for this prism, the two bases parallel for this prism, and the two bases parallel for this prism. Okay? So every prism has a base polygon, and it's duplicated. And then you simply connect the two exact copies of the base with walls, with lines. You connect all the vertices, right? These two vertices are connected by a line. The back two vertices are connected by a line, and these two vertices are connected by a line. The walls of these objects, the walls are called the lateral surfaces. The lateral surface. Okay? So lateral means sides, basically. So you have bases and you have sides. The bases are exactly the same polygon. It could be any polygon, rectangle, triangle, trapezoid, parallelogram, anything. And the reason these are called right prisms is because the base polygons are perpendicular to the walls. These are all 90 degrees. So in other words, the two bases are directly above and beneath one another. Okay, so you might be wondering what prism looks like that is not a right prism, so I'll draw one for you. In this example, the two bases once again are triangles. However, the top base does not sit directly over the bottom base, and so you can see that the angle that the walls and the base form is not a 90-degree angle now, so this is not a right prism. So now let's discuss how to calculate the volume of a right prism. The volume of a right prism is how much space the entire object takes up inside and everything. So the way to calculate it is to start with your base. Calculate how much space your base takes up. Alright? And so in each case, the base is a two-dimensional object, and so the space that a two-dimensional object takes up is called the area. So you calculate the area of your base, and you can see the three bases here are different shapes, meaning to calculate their areas you have to use different formulas, right? To calculate the area of a triangle is different than calculating the area of a rectangle. So the area of the base depends on what shape it is. Then, to fill up the third dimension, to get that height dimension on it, you take the area of the base and you multiply it by the height of the prism. So you take the area of the base times the height, and that will give you the volume. Notice the area is a two-dimensional value, and the height is a one-dimensional value, and when you multiply those, you'll get a three-dimensional value. Okay, let's talk about surface area. Surface area means the area of the skin of this entire object. Simply the outer edges of it, the skin of it, the whole thing. So to calculate the surface area, it would make sense to first calculate the area of your bases. Okay, so the area of your bases, and you have two of those, so you'd multiply the area of the base times 2. And then you would add the areas of the walls, the lateral surfaces, right? So that's called the lateral surface area. Okay, so how do you calculate the lateral surface area? Well, you could calculate the area of each of the walls separately, but that would take a long time, so there's a better way to do it. You want to think about taking the perimeter of the base, just the perimeter, and multiplying that perimeter by the height, so that you're sort of extending it all the way up, and you're filling in the skin of the walls, right? So you take the perimeter times the height.